We have a certain virus that infects 1 in 400 people. A test used to detect the virus in a person is positive 80% of the time if the person has the virus. That's called a true positive. And that test will be positive 8% of the time if the person does not have the virus. That's called a false positive. And I've color-coded the table we're going to fill out for this. Given this is a table of numbers that are related, this is a great place to use a spreadsheet. So I'm going to show you how I'd use a spreadsheet. It is possible to copy and paste a similar table or just type it up yourself. I have one started here, and I just need to adjust a little bit. I want this to be 1 out of 400 instead of 1 out of 200. And I'm going to have an 80% true positive rate and an 8% false positive rate. So to make the calculations here, I just have to think about what does it mean to be a true positive, and that was given in the description. A test is used to detect the virus in a person is positive 80% of the time if the person has the virus. So of all the people that have the virus, 80% of them will test positive. So that means I just focus on this first row. So in the first row here, my true positive rate of 80% of all the people that have the virus will test positive. So I want to know equals what is 80% of times that 250 people with the virus. So I'm going to get 200. The other 50 people are going to be negative, and that's just a subtraction. So I can fill in this by just subtracting the total of that row, taking away the positive from that. So there's 50. The false positive, let's look back at the description. The test will be positive 8% of the time if the person does not have the virus. So of all the people that don't have the virus, so all the people in the second row, 8% of them will have a positive test even though they don't have a virus, right? So the test was incorrect, it's false. So to fill in this cell right here, I want to know what is 8% of the number of people that don't have the virus. And then the remaining people from that 99,750 are just the difference between these two numbers in that row. So here I'm just going to take the total of that row, subtract the number of false positive cases for this instance, and I've got that there. All right. Now I want to know how many people total tested positive, so I'm just going to sum those two columns. And I want to know how many people tested negative total. So I want to sum those two columns. Sometimes Google's recommendations are correct. And the next thing I want to check is, do these two numbers really add up to my initial population of 100,000 people? So underneath here, I'm just going to put a little check for myself. If I sum these two new numbers, do they really add up? And it looks like they will add up. Cool. So I'm just going to get rid of that now. All right, so now we have a couple of other questions to answer. So let's take a look at our other questions. So once we fill out the table, we can answer all kinds of questions about this particular testing system. We want to find the probability that a person has the virus given that they tested positive. So in this case, of all the people who tested positive, I need to know what proportion of them have the virus. So in this case, I'm just focusing on the positive column. So again, find the probability that a person has the virus given knowing if they tested positive. So virus if they test positive. So probability they have the virus. I'm going to use the vertical bar we use for probability, knowing they tested positive. So that means I only care about the positive column. That's my denominator, that total. And in that column, I only want to know about the people with the virus. So in this case, I would go equals, click on my 200, and then divide by my 8,180. So as a decimal, it would be about 0.02 200ths. As a percent, that would be 2% or 2.4% to the nearest tenth. This question asked for us to state the answer to the nearest hundredth of a percent. So we have a lovely convert to percent button, and by default, it does the nearest hundredth of a percent. So in my version, I have a 2.44% chance that somebody will have the virus knowing they tested positive. Next question. Find the probability that a person does not have the virus given that they tested negative. So of all the negative tests, we want to know what proportion of those negative tests did not have the virus. So I'm in this column of negatives, and I want to consider the proportion of people without the virus in that negative column. So in this case, I want the probability of no virus knowing given if they tested negative. So that knowledge that they tested negative forces me to work only in that column. And in that column, I want the proportion of people who had no virus. So that would be this 91,770 divided by the 91,820. And converting that to a percent to 2 decimal places, I have 99.95%.